Okay, so to do the last homework problem, we have sulfur reacts with oxygen to produce sulfur trioxide gas. So for this one, we're going to just use sulfur. We're not going to worry about the S8. So sulfur reacts with oxygen. Oxygen is diatomic, and it produces sulfur trioxide. The tri means 3, just like tricycle has 3 wheels. And now I need to balance it, and so to balance it, I end up getting 2 oxygen, 3. So I'm going to switch the 3 here and the 2 there. That gives me 6 oxygen, 2 sulfur, 2 sulfur. And so those are my balanced coefficients that I'm going to use to do the rest of the problem. Now, if sulfur, so 6.3 grams of sulfur, react with 10 grams of oxygen. What is the limiting reactant and how many grams of sulfur trioxide forms? So if you'll remember when we first did stoichiometry, I got you to write the amounts given underneath the species in the balanced equation and then put a question mark on what we don't know and the unit, how many grams. So this is good to go. So now I don't really have to go back and read the problem anymore. I already know what I'm looking for. I'm looking for the mass of this. So here we go. And I lost my blue pen. So change to pink. So we're going to take 6.3 grams of sulfur, and we're going to use our flow chart. And we're going to go from 6.3 grams of sulfur to moles of sulfur, and then from moles of sulfur we're going to go to moles of the product, and then to grams of the product. So that's our flow chart. So I'll put it up there so we can keep up with what we're doing. Okay. So from grams to moles, I need the molar mass of sulfur, which is 1 mole of sulfur weighs 32.07 grams. Grams go out. And then to go from moles of sulfur to moles of the sulfur trioxide, I'm going to this unit. It goes on top, 2 over 2. So that's 1 over 1. So you can either put 2 over 2 or 1 over 1. Doesn't matter. So I'm just going to go ahead and reduce it. 1 mole of SO3 to 1 mole of sulfur. Units cancel again, and now I have the moles of B. And I just have to get grams of B. So I need the molar mass, so I may as well figure it out up here. Molecular weight of SO3 is sulfur is 32.07 plus 3 times 16. And when we do that, we get 32.07 plus 3/16 is 48, 80.07. So 80.07 grams of sulfur trioxide and 1 mole of sulfur trioxide. And we're done. And now let's work on magic with the calculator. Any numbers in the numerator get multiplied, these get divided. So it's going to be 6.3 divided by 32.07 times 80.07. And that gives me 15.7, carry extra, 15.7 grams sulfur trioxide. Okay. Now let's work on the other reactant. So this I'm going to tell the grader this is the sulfur. If sulfur's limiting, that's what I'm going to make. Oxygen is my other reactant. If oxygen's limiting, we're going to take 10 grams of oxygen. 1 mole of oxygen weighs 2 times 16, 32 grams. And then oxygen to that is 2 to 3. So 2 moles of the product will be produced for every 3 moles of oxygen that react. Grams cancel, moles of oxygen cancel. And now I just got to go to grams. So what was the molar mass of that? 80.07 grams of sulfur trioxide to 1 mole. And so let's see what we have. 10 divided by 32 times 2 divided by 3 times 80.07. That's 16.7. So close. Okay, so if I've done my calculator punching correctly, this is what we have. So, which is the least amount? This one. So this is my answer. That's the amount of sulfur trioxide we're going to get. This is not accurate because I ran out of sulfur before I could make that much. And so this is my limiting reactant. So what did the question ask us to find? What is the limiting reactant? So we say sulfur is the limiting reactant, and 15.7 grams of SO3 are produced. And this is my claim. That's what I'm claiming. All right. Now if I come down to the last point, last question. If 7.01 grams is actually produced, what is the percent yield? Okay. So, percent yield. Percent yield is the actual yield from the experiment over the theoretical yield and that's stoichiometry times 100. So a good way to think of this is percent yield is the meaning actual, over the theoretical, which is what you calculate from the stoichiometry. So this would be our theoretical. So this is going to be theoretical. That's your theoretical yield. In a perfect world, you're going to spill some when you're doing the lab, right? You're not going to transfer it all. We do the best we can to lower our percent error, but we're still not going to be perfect, right? So actual yield is what you get in the lab. When you do the lab, how much did you actually make? And they told us that we actually made you go back, 7.01 is actually produced. So 7.01 grams of hydrogen was actual. Oh, sorry, wrong problem. I went back to the previous problem. We were making sulfur trioxide. Sulfur trioxide was made. The theoretical said we were going to make 15.7 grams times 100, and that's going to give us less than 50%, isn't it? Times 100. 44.6%. So 44.6% yield of SO3. This is my claim. Oh, you couldn't see what I was writing, sorry. So I'll talk back through it. Okay, so this is our definition. In a perfect world, we're not going to get our stoichiometry amount. We're not going to get that in a perfect world. That's what we would get, but we don't live in a perfect world. So what do we actually get when we do the experiment? They told us we actually got only 7.01 grams of sulfur trioxide. And so we take the actual yield, what we got in the experiment, divided by what we calculated from our stoichiometry, times 100, and that means we really only got 44.6% yield. And that's how you do percent yield.